Next example. This time we are having a circular lake. A circular lake. Okay? And a nearby straight road. And somebody has decided they know the equation of the road. The equation of the road is 4x plus 3y equals 12. Why do you say it's simple? It's a straight road. That's the equation of a straight line. And somebody else also knows the equation of the lake. This is so unreal, isn't it? Anyway, here we go. X squared plus y squared. It is from a textbook, yes. I don't know anybody in real life who goes around working out equations of lakes. X squared plus y squared minus 10x minus 8y plus 32 equals 0. And all measurements are in kilometres. Mind reader back there, okay? And the question, have you any idea what the question might be?
Prove that it's a tangent.
No.
Find the length of the tangent in kilometres.
What it is, find the shortest distance. What's it going to be then? Find the shortest distance, what do you reckon?
From the road to the lake.
From the road to the lake, yes. From the road to the lake. There are no mention of ducks in the question, but there could be. Right, there we go. We have a circular lake. We've got its equation. We've got an equation of a road. What do you think it might be useful to do to start with?
Rearrange the equation.
Why? Hey, why are you rearranging the equation?
So you can complete the square.
Right. Hang on. What are we going to start with? The road or the circle? What do you want to start with?
Circle.
Circle. Okay. So, if we start then with a circle, also known as the lake. Okay, and we do what we normally do to it. Put the x bits together, and the y bits together, and the numbers on the other side. I'm not going to talk through each individual bit here. I'm hoping you're able to do this, but I am going to pick on somebody, and I'm going to pick on Emma. Can you pick on somebody, please, Emma? Choose somebody. You chose you. Okay, Emma. First bracket here. What's it going to be?
X minus 5 squared minus 25 outside.
Okay, choose somebody else.
Heidi.
Heidi, next one.
Y minus 4 squared. Minus 16.
Good, okay, I'll put a plus in there. I'll put my minus 32 there. People may well be ahead of me here. But I am trying to write down all the bits. Right, has anybody worked out what that is on the right yet? 9 or 9?
Well, it's 9 and then so it's 3 squared.
9, 3 squared. Okay? Yes, that is what I've got down here. That is what it should be. Okay? So, what do we know at this point? We know its centre is 5, 4.
Minus 5. No, that's wrong. That's stupid.
Okay? Yeah, this is right.
Yeah, I know.
Yeah, that's fine.
Sorry.
And the radius is 3. Okay? Right, I'm not going to draw that yet. Okay? Let's look at the road a minute. The road, the line, which was 4x plus 3y equals 12. If you were going to sketch that at GCSE, Callum?
Rearrange it.
No, you wouldn't.
Yeah,
Well, I wouldn't.
I would.
No, we don't want to know that.
You do it at the box and work out.
No, I wouldn't have done that either.
What's the question?
How would I plot? How would I sketch that at GCSE? Think. There's another way which lends itself to this. Go on.
Would you replace X?
No.
I was going to say it's X equals 0 and
Yeah.
Y equals
Oh, all right then. Yeah, I call it a cover-up and cover things up. But yes, you're quite right. Yeah. Okay. You not heard of it called the cover-up method?
No.
All right. Okay. If you let x equal 0, as we had the suggestion, that makes 4x 0. Effectively, you can cover the x bit up, which is why sometimes it's called the cover-up method. If x is 0, you can cover that bit up. You get the equation 3y equals 4. So what must y be?
4.
Anybody, that was 4. Okay? Are we happy with that? Did I say 3y equals 4? Sorry, I meant 3y is 12. It's the end of a long day, I'm tired. Right, next thing. You let y equal 0, which means you can cover up the y bit, because that's 0. Cover up, and I'll be very careful what I say here. You get 4x equals 12, which means x must equal 3. Okay? So what I'm going to do first of all is just a mini sketch. Okay? A mini sketch. I know this goes through 4 there and 3 there, and that line looks like that. Okay? Now I will do my proper sketch, and I will start off by doing my circle first, because I think it's the easiest way to do it. Probably. Okay, there's a lot going on here. Right, there's my circle. The radius of my circle is 3. Will that circle cross any axes? No, because it's 4 above. No, it's not. It's 4 to the right. No, it's not. It's 4 above and 5 to the right. It's not going to cross any axes. So next thing I'll draw my axes in. Okay. Now I'm interested in 4 up. Ooh, what's the significance of 4 up?
Oh, that's alpha. Very
But in relation to what I've already got on my drawing.
It's the same.
same.
Yeah, it's the same as that height, isn't it? So that 4 is there. 3 across is not as far across as the centre of the circle. So let's put that down here. And that gives me, using my makeshift ruler, a bit of paper here. Oh, I meant to have a different colour. Right. There we have our road. Sorry, there we go. So I've got my road, and I have my lake, and I have my axes. And everything's in sort of the right place. Okay? I've got nothing crossing that shouldn't cross. Everything in roughly the right place. Hasn't got to be to scale, but at least you've got things in the right position. So, how can I show the shortest distance from the road to the lake? Measure it. It's not to scale. Measuring it ain't going to do it. Go on.
Would you do like a perpendicular bisector which also goes through the centre?
I certainly like at least 2 of those words. Perpendicular, going to the centre, but perpendicular to what?
Perpendicular to the straight line.
Yeah, the road, that's right. The shortest distance will be that distance there, where that is a right angle. This bit here, this extra thick bit, what is that extra thick bit? That's the radius. Yeah, that's the radius bit. So I need to find out this extra little distance here, and if I add that onto the radius, I have what I'm after. Are we all okay up to there? Right. Yes.
Are you supposed to work to the centre of that bit? Because it just says to the left.
Oh, you're quite right, actually. Yes. Thank you. I said that wrong, didn't I? What we're after is actually just that bit there, isn't it? Yep, well spotted. Thank you very much. Actually, we're just after that bit there. Okay. Right. Any ideas, folks?
Oh, I don't know. You find the length of the bisector.
Right. Well, let's just take stock a minute of what we do know. I know the equation of the road is 4x plus 3y equals 12. I know that. Okay? Right, now. Is there anything else I know about that line? I know its equation.
Straight.
I know it's straight. Is there anything else in terms of numbers I can work out quite easily of that line? It's perpendicular to the radius. What else can I work out fairly quickly about that line? It's gradient, yeah. The gradient of that line. Look at this triangle here. What is the gradient of that line? Yeah. It's the vertical bit, it's 4, over the horizontal bit. It's going downhill, it's negative. The gradient of the road is minus 4/3. Okay? That comes from this triangle here. Okay, it's gone down 4 and then along 3. So the gradient is 4 divided by 3, going downhill, stick a minus sign in it. So, what does that now enable me to know next? Think back to the last example. The gradient of the,
line coming off the-
yeah, can I call it the radius?
Yeah.
It's the gradient of the radius. How do I get from the gradient of the line to the gradient of the radius? You saying it? Yeah, negative 1 over, because they're perpendicular. Negative 1 over minus 4/3. If you don't like that, that means minus 1 divided by minus 4/3. Keep, change, flip. And minus times a minus gives you a, and 1 times 3/4. Yeah. So, okay, the gradient of the radius is 3/4. Now I know the gradient of the radius. What could I find quite easily? What to do what? So I'm, yeah, the equation of the line. If you know, then go and find the equation of the radius, which will be y equal mx plus c. I know that that 3/4 there is that m, that's the gradient. What did I do last time to find out a c value? Put a point in. What point do I know lies somewhere on the radius? That point 5,4. So if I now substitute in the point 5,4,
Where's 5,4?
Yeah, how's that on the radius? That's the centre.
That's the centre.
so therefore it's on the radius. Can we just bear with me 1 minute, okay?
Oh, yeah.
So,
yeah.
if I use that, substitute that in. Okay, substitute that in. Sorry, that should have been a 5 in there. That's a bit scruffy. That will tell me that C is 1/4. And if I just... What have I done now? Turned it negative in my excitement to get the end lesson right. Okay, that will then give me the equation is y equals 3/4 x plus 1/4, which is just a wonderful place to carry on next time I see you, he says. Okay, these questions are long. Can I recommend that all of you, before next lesson, watch today's long examples again? You may not get it all first time round. Watch these videos again, please, before I see you next lesson.